So, hello everyone. Good evening. Can you hear me? Probably yes. Perfect. Thank you for joining us. My name is Evelina Bintevinou, and I am a scientific researcher at Danaos shipping company. Today, I will be moderating the session and presenting the topic of voyage optimization through the lens of artificial intelligence. I would like to thank BS Group for organizing this initiative and StormGeo for sponsoring the session. So, among today's speakers, we are pleased to have Peter Andersen, Vice President Shipping from StormGeo, Lajos Holmslykke, who is the Head of Voyage Optimization at TORM, then Pasquale Bisogno, who is the Deputy Head of Performances and Decarbonization at D'Amico Ship. So as you may already know, as regulatory pressure increases and the demand for more efficient operations grows, the maritime industry is increasingly turning to AI-driven voyage optimization to support smarter decision-making across the entire voyage life cycle. So in this session, we will explore how predictive analytics and machine learning can improve the accuracy and reliability of voyage planning, support real-time operational decisions, and also help operators remain aligned with evolving emissions regulations. We will also discuss how AI enables strategies that can help companies manage the economic impact of carbon pricing, ultimately reshaping how vessels plan, execute, and optimize its voyage. So let me share my screen in order for you to see my presentation and begin this session. Perfect. So I suppose you can see my presentation right now. And let's start. So, a few words about my background. My work focuses on the application of advanced technologies and innovative methodologies within the maritime sector. I contribute as a team member, work package leader, and scientific coordinator in several European research and innovation projects, including DD4GS, EO4EU, SafeNav, Warrant, and Bintevinou, among others. So through these projects, our goal is to bring practical, intelligent solutions directly on board vessels, which is exactly the perspective behind today's presentation named Voyage Optimization with the Lens of AI. If you have any questions during this session, please make a note at the Q&A section, and we will be happy to address them at the end of the presentations. So let's begin. So before I dive into today's topic, I'd also like to briefly introduce Danaos Shipping Research Center. Danaos has been a leader in maritime research and innovation for many years, with a participation in more than 40 European research projects funded under different EU programs. Our research spans the full maritime spectrum, from energy efficiency and navigation safety to operational optimization, and has resulted, as it writes down there, in hundreds of deliverables, software tools, and optimization models that support the maritime industry's continuous evolution. So today, I'll show practical AI solutions already supporting voyage optimization on board vessels. These technologies are not futuristic. They're actively improving efficiency, safety, and decision-making at sea. So we focus on two main areas: energy efficiency, AI systems combining machine learning, deep learning, gray box modeling, and IoT, Internet of Things, monitor vessels' performance in real time. They track fuel consumptions, detect anomalies, identify underperforming equipment, and provide actionable recommendations, optimizing speed, power, and machinery use, resulting in reducing fuel consumption and emissions and supporting regulatory compliance. Then we have navigational optimization, which means AI-assisted navigation, route optimization, Earth observation data, and predictive models enhance all this situational awareness, identify hazards, and also recommend optimal routes that balance safety, weather, and efficiency. These examples show how AI is already reshaping the maritime operations, integrating the efficiency, safety, and sustainability into single actionable framework, delivering real value on board. Then we have the AI toolkit. The AI toolkit is made up of key components that work together to create the intelligent systems. Machine learning, data processing, supervised and unsupervised learning, and artificial neural networks, which enable a system to learn from and process data, IoT, big data analytics, and finally, large language models that allow machines to understand and generate human language for more advanced interactions. So let me walk you briefly through the end-to-end Danaos fleet performance management ecosystem, from onboard data collecting to shore-side decision-making. At the foundation is the data sourcing layer, or the IoT infrastructure layer, where data is gathered on board through systems like Lajos, Mallorca, and Enviram. This data also comes from two main areas, the bridge and the ECR, the engine control room. From the bridge, we have the navigation systems like EGDIS and the Voyage Data Recorder that provide position, speed, and other navigational parameters. From the ECR, machinery and operational data, we collect them, and they come from systems such as the alarm monitoring torque meter, the flow meters, etc. Then data is transmitted through an onboard wireless network, processed at the edge for quality and consistency, and then sent ashore via a reliable satellite, via all the reliable satellite links. Then we have the onshore, a dedicated server that receives and stores and forwards the data for near real-time analytics. At the headquarters, the Waves core system integrates and analyzes multiple data types, structured, semi-structured, and unstructured, and external sources like weather data, transforming all this data into actionable insights. Then Waves operates in 4 tiers. Then we have data quality, which is the validation, homogenization, and as you can see here, integration. And then the intelligence, which is the KPI evolution, benchmarking, anomaly detection, and AI-driven predictions. Then we have the visualization, which is all the dashboards and the displays that we have. And the decision support, which is rule-based and AI, and we have the AI recommendations to reduce the operational uncertainty. Finally, we have the user applications that provides all the shore-based access through secure web browsers, offering us all the dashboards and tools for performance monitoring, emissions, also route optimization, propulsion tracking, and hull performance. In short, all the infrastructure and the integrated concept topology that I just described is how the data flows seamlessly from onboard IoT systems through Waves to actionable insights, enabling us with real-time informed decisions that optimize fleet performance, efficiency, and sustainability. Having seen how the Wave system connects ship-to-shore data, let's zoom out to the broader digital transformation in shipping. So at its core, are digital twins, virtual models of vessels that allow simulation, monitoring, and optimization without affecting the real asset, the ship. Some update in real time, while other update more periodically. So, before exploring the analytics pipeline, let's cover what makes a digital twin effective. It must accurately mirror the physical vessel that enables us by three key elements: the sensing, the sourcing, and the communication. First of all, the sensing means that we collect all the detailed data from sensors like flow meters, torque meters, also emission analyzers, and then navigational instruments such as GPS and gyros. Then we have the sourcing that involves gathering all the relevant data streams. Then we have communicating that ensures continuous secure data flow between the ship, edge devices, and shore. So now that we have established the foundations of the digital twin, and especially the importance of sensing, sourcing, and communicating all the information, the next step is to see what actually happens with all this raw data. Because collecting the information from everywhere is only half the story. So to make it usable for AI to feed it into machinery learning, also deep learning, or any model library, we first need a rigorous pre-processing pipeline. And this is exactly where our applied research begins. On a typical vessel, we have flow meters such as the Contoil, torque meters like LeMag that provide effective horsepower and RPM through RS422 and NEMEA protocols, and continuous emissions monitoring systems. Then we also gather all the voyage-related signals, GPS, speed logs, as I already told you, gyro, anemometer readings, usually transmitted over the NEMEA 183 standard. And companies like Horiba, who complement this with high-precision analytical instruments widely used in the maritime domain. But once all the information arrives, it is not clean. Raw sensor data always contains noise, missing values, outliers, and inconsistencies. So the first thing we do is apply clustering algorithms to understand the structure of the data. For example, k-means help us partition the data space into Voronoi cells, especially grouping similar operational states all together. Then we have dbScan, on the other hand, which is great for detecting the dense clusters and isolating the noise. This is especially important in maritime datasets, which are almost always noisy and very multimodal. Then to understand how variables interact, we use Pearson correlation, which allows us to see which measurements move together independently of their units, and this correlation step is often what guides our modeling strategy later on. It tells us which signals actually matter for prediction, anomaly detection, or performance modeling. So all these processes, collecting, cleaning, clustering, and correlating, form the backbone of the digital twin. So all the data we collect, clean, and structure feeds into the modern digital twin, an AI-powered living replica of our asset, the vessel. It combines sensors, streams, logs, navigation, weather, engine, and structured data with advanced AI. Machine learning detects the trends, predicts the failures, improves efficiency. Deep learning enables us with pattern recognition, anomaly detection, and long-term forecasting. Then we have the LLMs, which interpret unstructured data like logs, manuals, reports to provide recommendations and decision support. Then we have the model libraries, which covering engines, fuel, hull, hydrodynamics, weather, and risk create a complete virtual vessel. This allows us with what-if scenarios, fault testing, and optimization before applying these changes in the real world. As the systems evolve, they support autonomous decision loops, making the digital twin an intelligent companion that can continuously learn, predict, and advise the digitalized ship. Then here we have this is a supervised prediction model, which is a very classic example of machine learning. We use historical data related to fuel consumption, meaning variables that directly influence consumption. In supervised learning, we have known inputs and known outputs, but we don't know the internal relationship between them. So the model learns this relationship for us. In our case, the known variables include fuel oil consumption in tons per hour, as you can see here, displacement with its loading condition in tons, speed through water, effective horsepower, and draft. So by feeding these historical data sets into the model, we train it to understand how these factors interact. During training, the system learns the coefficients and the relationships that define the vessel's performance behavior. And once they're all trained, we can give the model new input values, and it provides a predicted fuel consumption based on the patterns it has learned. So as you can see here, in simple terms, we use real operating history to teach the model how the vessel behaves. And then, excuse me, sorry. And then, sorry, let me see where I was. Okay, and then it predicts all the consumptions under the future operating conditions that may be caused. So for this slide, I would like to present a practical application of the concept in an operational context. So this example illustrates an AI-driven route optimization system. So the approach is based on the integration of multiple data sources, including meteorological forecasts, oceanographic conditions, such as waves and current data, satellite observations, and real-time vessel performance parameters. So using this information, the digital twin simulates the vessel's behavior under different environmental conditions and evaluates all the alternative routing scenarios. So the objective is to identify the route that minimizes fuel consumption and transit time while maintaining safety and operational constraints. So rather than focusing on the underlying mathematical complexity, the key point is that the system provides data-driven decision support by continuously updating its model with real-world information. Then, on the next slide, you can see a video which is self-explanatory, and it is a weather routing optimization model platform. Here you can see that we have diagrams with speed through water, the average fuel oil consumption per hour. Then, in this slide, I'm going to present you the EO4U EU project. So, to be more specific, I will present you a practical application of an AI-driven route optimization. So the system integrates multiple data sources, including weather forecasts, waves and ocean conditions, satellite information, and real-time vessel performance data. This is an EU project that the Danaos Research Center is involved, and especially in this use case 2, which is the ocean monitoring. So this information is processed by a digital twin, which simulates all the vessel's behavior under the expected environmental conditions. Based on these simulations, the system evaluates all the alternative routing options and identifies the route that optimizes efficiency while maintaining safety and operational constraints. So the goal is to reduce fuel consumption, avoid severe conditions, and improve overall voyage performance. So on the left side of the slide, you can see the main categories of input data used in this process. The key idea of this is very straightforward. The more accurate and comprehensive the data, the more reliable will be the predictions of this model. So thank you very much for your attention. It was a pleasure sharing our work and the latest developments with you. And from an industry perspective. Next, I'm gonna stop sharing my screen. And then the next speaker will be Peter Andersen, who is the Vice President Shipping at StormGeo. And Mr. Peter?
Thank you, Evelina. I will share my screen here, and then you will let me know when you see this. A second. You see my full screen now, Evelina?
Yes.
Very good. Thanks for that, and thanks to all of you for listening in to this webinar. So myself is Petter. I'm representing StormGeo here today. I'm a Vice President of Shipping, sitting in Norway and Oslo. So I wanted to give a bit of a practical approach on how we see and how we use AI tools to support us in our delivery, specifically around voyage optimization. So that's the main topic for today, and also looking forward to some more questions later on. But before I give you some use cases, which I will explain, I would just say a few words about StormGeo as well. Maybe some of you know us, maybe some of you don't. We have been here for more than 25 years, so relatively young company, depends on how you define it. Our owner in the background have been here for many more years, Alfa Laval in Sweden. They are our full owner of in StormGeo. So we are a global company in all the time zones. And we are based on weather forecast. But today, 60% of what we are doing is in shipping, and 40% is in other businesses, onshore, offshore, all based on weather intelligence and weather forecast. So for our shipping delivery, this is our foundation, and we translate this into value to our shipping customers. So I said that I wanted to give some use cases, also building on some of the elements that Evelina has talked about already. But before we do that, let's talk a little bit about voyage optimization, current challenges, and actually how we deliver this today, because then we can hang these use cases more onto our delivery, making it practical. So it is for sure a more and more challenging environment to sail and operate ships today for many reasons. It's never been straightforward or easy, but the environment today, it's making it more complicated. It is a fact that the weather is getting less predictable. We see trends in changing weather patterns, and sometimes it's also not so easy to predict some of those trends. So that means that specific and challenging weather conditions can happen more and more faster. The storms are getting more stronger, and the weather is imposing an additional risk element for all ships sailing from A to B. Voyage planning today is also not getting easier. There are very many factors to consider, which I will get back to in a second. It's not only the safety and efficiency, it's also about CO2 emissions. It's about planning the right bunkers to use, It's about minimizing the cost for any emissions in and out of EU. All these things, elements, is a key part of the voyage planning today. And of course, this has an impact on the efficiency and the operation and the outcome of the voyage. Charters and owners today are including clauses about who to take the cost for fuel, maritime, biofuels, etc. It's getting more and more complicated, voyage optimization. So I say here, optimizing a voyage is based on really many variables. And that's not new, but again, the variables are not getting less, they're just getting more and more. So this screenshot here is from October last year, where we had this Hurricane 5 storm, Hurricane Melissa, passing over the Caribbean and creating some serious damage. I know that many of you remember that very well. It was a challenging situation for very many ships. And routing a vessel from A to B is about avoiding these extreme situations and also less extreme situations while maintaining a commercial delivery for the vessel. So I am listing many different elements here, which are continuously being taken into account by us and by you when you are planning and optimizing the routing. First of all, it's about safety. That is what the voyage optimization is about. Safety is always number one. It's about having the right thresholds set for the waves and the winds. It is about defining no-go areas. There are many regulations that has to be met, whether it's CO2 emissions or whether it's environmental regulations. Fuel costs, of course, is a significant impact. The fuel consumption, performance model, required time of arrival, all these elements make the optimization very complex. And the reason why I'm listing this up as well is that when we're talking about AI, there are now we're starting to see many interesting use cases for AI as part of this optimization. Some use cases are stronger than others, and we are testing now many of them to see where are the best use cases. I almost said low-hanging fruits. That's a bit simplistic term because this is not straightforward, but we see some really interesting use cases here, and that's what I want to talk about here today also, where we see the best usage of AI models per today. This is the same day, just took from marine traffic, where you see the storm, except we don't see it, but we see there is no vessels here. And this is, of course, how you as operators and also charters have to maneuver around these storms. And this is also what we do from our side. And as a note to this as well, we are using advanced tools already at this level, identifying which vessels need the special attention from us and which vessels do not. And here we use also advanced algorithm to make sure that our people, our staff, our global support staff have the extra support needed for those vessels in and around this storm, for example. So there we also use advanced tools to identify that, because not all vessels need full support from a route analyst every day. First example case I wanted to present there is that we have been delivering weather routing, voyage optimization for more than 20 years from StormGeo, so that's not something new. But we are developing new alternative ways of supporting ships as well. And I call this here AI routing, operator-driven route optimization. So this is referring to a tool that we have in our web platform for the operator onshore to do his own optimization. This is then moving some of the responsibility over to the operator, if that is the desired solution, and we use more automation and more AI-based optimization as a basis here. So it works this way that the operator will do his optimization, and when he can work with his route, and then when he's done with it, he will send it to the vessel. The vessel will import this on board and act on this and follow the route as it would have come from StormGeo. And the reason why I'm also talking about here today is that, yes, this is a digital tool, but there is an element here which is relevant when you're talking about AI, because everyone is thinking about and asking about, can AI replace the advice? Can AI replace the people on board, etc.? And at least if you ask us, we would say no, but it's a very good support and can make the advice more and more efficient, because very many sailed routes around the world today can be handled in this more automated AI-based way. So the way we set up this application, this alternative to our future routing, is that when certain thresholds are being breached, whether that could be weather situation or other, we get an alert, and then we can step in, a human can step in and give additional advice and really check that the situation is safe. And this is, there's a lot of talk about human in the loop, which is fine, but then if you have a human in the loop, the human is involved in all the decisions that's being made. So this is more a human on the loop type of delivery, where the human, in this case, our routing experts, are monitoring the situation and they are interacting if there is a need for it. So this is one interesting use case that we see as a good alternative, because with such a more automated delivery, we can provide assistance via our tools and indirect support to more vessels and more routes than we can do today. So it's an efficiency thing. We can cover more routes, deliver more than we can today. That's a perfect use case for more automated AI-based routing. That is the first case I wanted to talk about. And the second one is more of a foundational thing, and you mentioned it also, Evelina, about vessel performance models. And you talked about digital twins, and in practice, the same as I'm talking about here, I'm just calling the vessel performance models. So how we have been doing this for decades on StormGeo side, delivering route optimization to vessels, is that we have been using our historic available data, and we have been putting this together in speed consumption curves for all typical ship sizes and categories. That's not a bad solution. And we still use that for very, very many purposes, but we're also exploring how we can use an AI machine learning process to further improve these curves. And that is also a very good use case, because the studies that now we are doing, we see that you can increase the accuracy of the model, which basically then means in this weather situation, this wind direction, this wave height, at this position and this water temperature with this specific vessel, what is the expected consumption of the vessel? So we see an increase of many percentages of compared to the statistical performance models based and the AI based performance models. That's also a very good use case. And technically it's interesting, but I mean the outcome here is that if you have a better model, you can do a better pre-voyage planning. You have a more accurate prediction of the consumption for that voyage. You have more accurate estimation of the CO2 emissions for that voyage. And that has a cost, at least today when you are sailing in and out of Europe, for example. And it's also about, I mean, guiding a vessel, you need to know where it is at all times. And in order to estimate that, you need to have good weather factors as well. You need to know how this vessel is behaving in a given weather situation. And these AI performance models, they're also very good there because they will continuously improve and also take into account the actual condition of the vessel at that time, not just from the vessel was cleaned eventually last time, but it's the actual condition of the vessel. And of course, this is interesting by itself, but it's really interesting when you put into a context, into a delivery. So the last example I wanted to share here as well, talking about voyage optimization. We have more examples, but I wanted to limit it down, not too many. It's about just-in-time arrival. So optimizing the speed of a vessel has a huge impact on fuel consumption for the vessel. And of course, that has a cost element to it. So by planning the ETA more sharply against in this case, the expected waiting time you have in an export can save a lot of money. So we are working here with a third-party company, a partner, where we are combining their expertise in using AI analytics to estimate the waiting time in the next port. So we're combining that information with our voyage planning, such that this screenshot here from our portal will show for my vessel here, where I'm sailing towards Barcelona. I'm seeing here what is the expected waiting time when I am arriving. So by having this information, then the operator can make a more informed decision about whether he wants to slow down half a knot, for example, or even more, if he sees that there is an expected waiting time over X amount of hours. So it's increased information to the operator so he can make better decisions. And then what else is the operator seeing on the screen here? He would see that his vessel, number 5 here, it's expected to arrive at 9 o'clock on Wednesday. And then he also see from this algorithm that the other vessels, which is not his vessels or her vessels, but picked up by AIS and estimated when they will arrive. So the operator here will not only see what is expected waiting time, he'll also see which other vessels is he actually competing against. And then by speeding up a little bit, he can also then influence the queue that he's coming into the port with. Of course, there are further elements in terms of who ends up first at the berth, but this gives him additional information to make informed decisions going into the port. So that is the another very interesting use case we also see, and it's down to pulling more efficiency out of the voyage by having the right sailing time during the voyage. And then just bringing this a bit together as well, I talked about voyage optimization, complexity, I talked about performance models and just-in-time arrival. So we bring this together because all these things, they are very fascinating by itself, but they had to be brought together. And that's the complicated part, to bring this into together an overall optimization algorithm. And in this case, presented then to the people on board that are making the final decisions on board the vessel. Because AI is great, but at the end of the day, it is the people on board the ships that's making the final decisions. AI is not changing the work process with that respect. So we bring this together and we present this to the people on board so they can do their optimization and get out the efficiency gains that you can get from a more accurate performance model and have more information related to the port congestion and just by itself doing a more accurate optimization along in between the weather systems that you will have with a good algorithm and also with an AI-based fuel model. And it's about fuel saving, and even if route optimization is about avoiding the worst storms and weather and minimizing the damage, in addition, it's also about efficiency. So by planning the right speed with a variable speed optimization, there is large fuel savings realistically that you can save on top of the already optimized routes in the range of additional 5% additional savings. And lastly here, I just want to sum up some numbers here about what we deliver. That was not, I will not go through all the numbers, just shows that we have a big footprint in the market. We have more than or close to 2,000 vessels using our EUVTS solution. But the red circle here I wanted to highlight as my final summary. We receive nearly 10,000 reports from vessels every day. It's a huge amount of information, and this we use to also train and learn our models. And my final point is that we can talk a lot about AI, but it's also that you need high quality data to train and develop an accurate AI model. So there is a lot more to it than just having a nice algorithm. You need to have the right data behind, and that's something which we're also working very, very thoroughly with to make sure that we have the best data quality delivered, also to be used for training AI models. That was my final part, Evelina, and I want to give the word back to you.
Thank you very much for this insightful presentation. Then we have Mr. Lajos Holmslykke, who is the head of Voyage Optimization at TORM, presenting. Mr. Lajos?
I'm not sure if we have him along
Yeah, I
still,
cannot see
Evelina. So
him
maybe he's showing
either.
up a little bit later.
Yes. What, Mr. Pascual, do you want to be next? And then I can hear you. Probably you have the mic off.
Yeah, good afternoon, everyone. Sorry, I was having some troubles with connection, but now it's fine. So thank you for your presentation to both of you. Basically, I'm going to share similar information from operation point of view. I am Pasquale from D'Amico Shipping. We are based in Rome. We are managing around 70 plus vessels. Between mostly between tankers or chemical tankers and bulk carriers. And technically, we manage the vessels between Rome office and Singapore under our full control, the Ishima International Ship Management. And we are managing also third-party owners and the vessel in TCIN as a performance department, for which I am the deputy head of the department. I'm going to share today some contents regarding the voyage optimization. Let's see if I'm able to. Uh, can you see my screen now?
Yes, perfectly.
Okay.
Perfect.
So AI adoption in our industry remains low in transport. Was confirmed during last IMDA in Singapore, which I have attended. It's very clear that, as Peter was saying, there are a lot of low-hanging fruits in our industry, which are waiting for to be enjoyed. So as you can see, digital adoption is very low, according to data of 2023 and 2024, as well for AI adoption, even with business and industries that are very similar to our let's say industry. So this is something on which we are trying to work. But sometimes when we face our processes to understand how to adopt AI in our let's say in our daily basis work, we are questioning ourselves to understand whether we are talking about a hype or reality. So of course we are trying to implement AI in many ways we can, but sometimes we're facing still some let's say recruitant attitude from especially from ship staff, not only. So we are checking, as I said, in our processes where we can implement and we can do better with the help of technology. And of course, we are working in many let's say phases in our industry. So we are not only ship owners, ship managers, but we are working also as port operators. So also for third parties, we are managing also. We are involved in a class society and so on and so forth. So there are many let's say areas where we can implement AI. But of course, today we are talking about ship operators, owners, charters as the optimization of voyage in particular. So this is what is our idea, and we have started this journey 10 years back. So the Fleet Operating Center that we call FOC. So in order to give in one shot the full picture of our fleet. So as I said, we are not managing only our own vessels, but we manage also third-party vessels and vessel in TCIN, where we are, in that case, we are charters. So also for those vessels, we like to understand what is going on, what is the fleet performance, whether there is something to do in order to increase the performance of the vessel or to optimize the voyage. So at board level, or a top management level, we can say we would like to have in one shot the full picture, so to understand the health, the status of the fleet in real time. So how is the situation now? The vertical solutions is starting from Frida 2. That is the second, let's say, edition of our QRT and data, let's say, collection from the vessel. It's a web-based web page where we take all data from the vessels by noon in Frida. After that, we have the performance, let's say, tool given by RINA classification, in which we have half of our vessels, especially on tanker side, where we have sensor data. This is a pilot, let's say, a pilot implementation we are doing since quite long. So we are implementing slowly on full fleet. After we have Kongsberg and Akonis, that are our main, let's say, automation providers. And in addition, we have Weather News International, that is our weather provider. Plus, there are some solutions like Celeron that are giving the performance of the engine. So not only we like to understand what is going on, let's say, on the hull and the propeller side, so but we like to implement let's say, to merge information also from engine side, especially on main engine and auxiliary engines. So on the prediction of weather, so we are implementing AI through our partners since long, so almost 3 years now. So we are having, as Peter was saying, we are trying to have as much as possible data we can, but it is important that this data are reliable. So we are passing from numerical weather prediction to AI weather prediction. So we are not relying anymore on physics equations, so deterministic tool to understand what is going on around the vessels, so as weather. But we like to take as much as data we can, so in order to have a deep learning model. So of course, to do this, you have to train the model. You have to understand what kind of information you are taking from the vessel, and what kind of information you are taking from 1,000 vessels, of course, that our partner is having, in order to train the model and give inputs to the future decisions. So for sure, the training model is going on since quite long, and now we can see after some time that the data are giving very precise information regarding weather. So when we talk about weather, of course, we are not talking about only about optimization of routing, but we are talking about also about safety. So there are many options for which we are optimizing our voyages. Of course, the end decision is belong to the operation department in cooperation with our clients, because most of our vessels are in TC out. So it's a decision that our operation is taking together with the clients. As a performance department, of course, we prepare the full information set. So, and according to the priority that they would like to give to the voyage, we set the next routing. So as I said, we pass from site-specific deep learning forecasts by long-term observation data training, from quality, from what was the just quality determinative forecast that was before. As you can see here from screenshot, basically what we do before to start a next voyage, captain, after dealing with operator department and our clients, is setting the information of next voyage. So in accordance to the priority that is given, our provider is giving at least 3 solutions to choose, and you can change anytime during the voyage if some parameters are changing, like weather or priority request or port congestion, and so on and so forth. So by doing this, by applying what is called OSR, so optimize ship routing, we are on average every year we are reducing the, let's say, the emission on about over than 100 tons of CO2. Unfortunately, we can do better, but that's true. But most of the time, the priority is not reducing the amount of emission, but there are some other priorities that clients are setting. But the things are going better and better with all these new requirement of ESG and trading in Europe and so on and so on and so forth. As you can see from the table below, so the machine learning forecast is independent from observation physics basics. So we are really going very close to the reality on what is going on board, and we can match our data with the data that the forecast is giving with our data on board. So on board we are having an accelerometer to appreciate what is the wave the wave height during the voyage, and also through anemometers in real time. Every 5 seconds we can understand what is going on board of our vessel. So as also was Peter was mentioning, we have set the alert triggering. So this is very important because sometimes what is lacking is the flow of information between, let's say, technical departments and performance department with the operation department. So sometimes there is no good understanding each other, even though we are working in the same office. So this is very important to set the trigger, the alert triggering together, to understand really when is the moment to change something. So under, as I said, first of all, safety point of view, and also, of course, our final goal, that is the optimization of the routing. So the alert is going, when the alert is going on, the vessel should receive an email, including let's say the technical department, technical manager of the vessel, and the operator is dealing with the captain to understand what to do next. So once you have the action plan set, the alert is closed. We have 1,000 alerts, of course, per day. So we are giving priority to those alerts that needs to have an action. And slowly, I see that the culture is changing. Especially the new generation of officers on board are picking very fast the new, let's say, the new technology. So the last tool, other than let's say weather forecasting and voyage optimization, is the AI agent that our weather provider is implementing, and for which we are partners in order to give our operation experience. This is a tool that is starting. It was implemented since 1 year. So I see that, of course, training and fine tuning the quality of answers and that the software is giving. I see that this is a very important tool that you can, let's say, you can implement in your daily basis job. So especially for us as performance, to quickly understand for what reason we have received a claim from our clients, in which period, for let's say, for what reason, and so on and so forth. It's a very fast tool that is giving information that you were before taking something like 2-3 days to understand what was going on. So this you can check from web-based software, or especially now they are implementing also on the mobile phone. So anytime you can check and questioning the AI agent on the information that we are getting from vessels, and information we are getting from weather provider, in order to have in one shot the full vision, full let's say picture on what is going on board. So the challenge of implementing AI is quite tough. I mean, because you need to use some case identification to prove that you have a benefit on this. So in order to be commercially wise. So of course, cybersecurity is a part of the journey. Again, as previous speakers were saying, accuracy of models is very important, because otherwise you see that you are going off track, and when you are going off track, you feel uncomfortable. So it's important that the data are very accurate, and this is something on which we are working on daily basis with ship staff especially, because finally the data are coming from ship stuff mostly, other than sensor data. And of course, training of people ashore and on board is very important to be everybody on the same page. This was my last slide, but I would like also to share my screen just to show what we are doing with our software on daily basis. As I said, we have the full picture of our vessels going around the world. So to understand what is going on with the colors, of course, many vendors are doing the same. So what are the criticality and so on and so forth. But going especially on AI tools, we can have in very short time, as you can see here, just a few seconds, you can understand what is going on around the world. So North Pacific Ocean, South Pacific Ocean, North Atlantic, and especially if there are any critical situation like here, tropical storm information, like a cyclone design. Just click on and you get this information. So that is very useful for captains on board, for the operator that is following the vessel, and for safety department, and also for us as performance, as we are discouraging our captain to go through this bad situation. So we are doing our calculation in order to understand how to optimize the next voyage. And as I said here, again, in one shot, you have all the fleet that are involved by bad weather. So in North Atlantic oceans, you see 4 or 5 vessels that are involved in bad weather situation, as well in Europe, North Pacific Ocean. So it's a very fast tool. And as I was as I was mentioning before, we have also an AI agent tool that I'm now loading. I don't know why it's quite slow. Okay, for which you can make an interrogation to the software anytime for the past voyages. So just start chatting, as we are using Chat GPT, that is the most famous in the let's say as software. So just questioning let's say the software for the past voyage, you can understand what was the reason of bad performance. So as you can see here, really in very short time, so we are talking about seconds, the software is telling us what is the reason of any delay, of any claim, or extra consumption, and so on and so forth. Just is taking a little bit time. As you can see here, there are any filtering regarding the information that you would like to have, reporting RPM, weather, current factor, waves, Beaufort, and so on and so forth. So still thinking. So he's saying the information of the last voyage. So I asked, in this case, for the vessel Cielo di Houston, is the performance so far caused by ship performance issues or weather? And he's answering in very few, let's say, less than 30 seconds. He's giving the full picture of the current voyage. So from January to February 9th of this year, he's saying that the weather impact evidence. So the data shows clear correlation between weather condition and speed loss. As you can see here, in a really short time, you can go strictly to the topic, to the point. So by doing our analysis and delivering the proper data to the department that is requesting evidence and information on what happened in the previous, let's say, or actual voyages. So I stop my sharing. So this was the last slide just to share what we are doing every day as department. So of course, AI is something that we can implement in our process, but sometimes it is very important to understand what we are doing otherwise, we had experience that sometimes AI is something that we are overthinking. I mean, it's not something magic. It's something that you have to train. As Evelina was saying, it's something that really you have to appreciate with the right numbers, reliable data, and with, of course, very, very, how to say, um, uh, very, very well trained models. Yes, that's all.
Thank you very much for this insightful presentation. Actually, it was very important for these days. Then let's next speaker is Mr. Lajos Holmslykke, who is the head of Voyage Optimisation at TORM. Please.
Thank you, Evelina. I hope you can hear me now. I had a little
Very
hiccup.
good, very good.
I could see you, but you couldn't see me. So let me
Yes.
try to share my screen. Just 1 second. I have it here. Here we go. I hope you can see my presentation now.
Yes, we can.
So what I will try to do with this presentation is to walk you through our, how should I say, voyage optimization world. So I'll not go into too many details about the technical setup and all the things you can do. I'll try instead just to explain where we use processes, where we use algorithms, and where we use AI. So and then just to set the scene, very important for us here in TORM at least. So we have little more than 90 vessels. We are always trading in tramp. Our vessels have the sizes of MR, LR, LR2s. Our goal is not to micromanage our captains. I'm a captain myself, but I have not been sailing since more than 20 years, and I cannot sit in the office and feel what it is like to be on board. My job is to make sure we have sensors so we have a better understanding and make sure we can educate and provide full transparency to our vessels so that we can give the best possible guidance, no matter if it's safety related, if it's voyage optimization, if it's performance, if it's weather, whatever we do. Our role is to try to build a world where we can be better in giving advice, because the result is very, very easily measurable when we see effective vessels, and it's immediately measured on the bottom line in our company. So that was just setting the scene. What I'll try to do is to walk you through the beginning of the voyage before it actually starts, when it actually starts, and then the analytics parts of it a little bit later. We have many partners, and we could probably find many more. But if we look only at the voyage optimization part, we need the commercial values. We have all heard about the AIS data. We all know the importance of the performance models and the use of data and algorithms to run the performance. We all know the importance of the weather, whether you build it yourself or you get it from a vendor. We get it from our vendor. We all know the importance of the route from the vessel so that we can implement it into our systems. And we also need decision support tools on board. In our case, we use StormGeo, so Peter is a close partner of ours. And we also use automation in running the algorithms for optimizing the voyage. What we built internally, a little bit similar to what Pascal was showing, is we build a system so that everybody can access the data. We have all the relevant information at the right time for the right people. So there are no secrets, never. But it's more the user, whether it's a commercial, it's an operator, it's a technical, it's a chief engineer, it's a first officer, or it's a captain, whoever it is, that person should always be able to use the same application, the same world, and then have the necessary information to do his or her task in a more effective way. That's kind of the ambition with everything we try to build and everything we try to do in our company. What we do is we obviously measure the resistance, we measure the performance, and then we prepare the passage plan. We try to work with seasonality. so that we can optimize the beginning of the voyage. There's no doubt that once you have started the voyage, AI systems or automated systems can easier today take over the passage and then do the optimization. But seasonality is also a big factor. And then obviously we have the execution where we do the optimization and the energy management. Energy management we have dealt with on previous sessions, so I'll not go into details about that, but it's a in this world where everybody's talking about optimizing and improving the CII and all the regulations about emissions and emission costs, it is of course and obviously a more and more important matter when you run shipping, when you run a vessel. Before we start a voyage, it goes into the seasonality part, but it also goes into the commercial people. I myself am actually positioned in the commercial department, so I have an interest in making sure that our commercial parties, they know exactly when the vessel will be made available. For that, we use algorithm-based simulations. So in real terms, in daily terms, what we do is that we simply run all our main routes every single day, all throughout the entire year, and then we gather the data. We gather the data to be able to provide statistical evidence of the hindcast. And in hindcast, I mean what happened last year, what happened last week, what happened last month. Because then once you have enough data, maybe 1, 2, 3, 4 years of data, you can start analyzing what can you expect for the season. And it's important for both the master, for his ability to calculate the ETA in the season that he's trading, but it's also important for the chartering person who needs to know when the vessel will be open, because we are in tramp. So our vessel gets opened, we deliver the cargo. When will the vessel be in the next port? We use algorithm-based statistics to understand what will the penalties be, because we're not a big container ship. We cannot just speed up. We have limitations on the power, just like many other shipping companies. So we cannot just run our way out of things. We have to understand the delay factors. We need to understand when can we expect the vessel to be made available. And it's not just dividing the distance with the ordered speed, it's adding the loss factor as well. And it's becoming a bigger and bigger issue the more bad weather we get. We have commercial decision tools. Like I said, we have our own internal system. It's called Nexus in our company. And in this system we have for the commercial, they can then enter their vessel and see when will the next vessel be open so that they can look for the cargoes. We can then make sure we inform what the delay factors will be using algorithm-based statistics to calculate based on the weather and the hindcast and the simulations, when will the next vessel be open. Next important part is also very essential. How shall we start the voyage? So no matter whether we are in the Indian Ocean, whether we are in the Atlantic, or whether we are in the Pacific, we need to understand what season we are in. A very experienced master, like Peter was mentioning, or a meteorologist from StormGeo, will know the almanac, and they can look up the hindcast historic weather, but it changed. And we need to follow that change. This year has been very strange. We have never ever had so many weather systems in the central part of the Atlantic Ocean, meaning that we could suddenly start going great circle across the Atlantic in the winter time. I don't think I've ever seen that before, and I've been in the business for more than 30 years. So we need to follow the development every single year. We use AI machine learning models to train with our energy models, to train with our added resistance in weather, and then to simulate how should we most effectively proceed on the coming voyage. This is a decision tool that we can then give to the master. We can also give it to the commercial party, so we have a better understanding of the ETA and of the fuel consumption, so that the master can start up his voyage. So it's mostly an advice tool, using AI-based algorithms and training models to understand where can we go next and what direction should we move in order for the season to move most smooth, avoid heavy weather damages, excessive consumption, loss of time, all these things. And then the following days, our algorithm-based routing optimization tools will then take over and steer the vessel out of the bad weathers. So that's then when we come into the actual voyage, and then the priorities on the actual voyage is then obviously avoiding the bad weather and sail with constant power. And here we use algorithm-based systems. We gather the data, we use the statistical performance models we have, and then we run with the current forecast in order to constantly advise the vessel to avoid the bad weather. And this we do like this. So we monitor the vessel for the forward forecast using the forecast wave, the forecast swell, the currents, and the winds. And we have our energy models and our speed loss models, and then we use those models to calculate what would be the most effective passage for the current voyage. But the priority set in real simple terms is not advanced AI. It's actually a very basic list where we control how much waves will we accept for a given voyage. If you are laden, part laden, drafted, ballast, clean, whatever you are, then how much weather should we try to avoid? Because that will allow us to simulate automatically the daily proposals sent to the master for him to import and review and then accept, if he like, the changes we have proposed. And that's how we use data, and that's how we use algorithms, and that's how we use AI. So we use AI to train our models, but we use normal algorithm-based data and models to steer out of the bad weather. On the energy side, we then simulate the voyage as it is planned, and then we reverse it, and then we simply look up what would be the most effective power to maintain a constant power throughout the voyage in order to maintain the ordered speed in good weather. There's no need to push your engine in bad weather. That would be outside the CP terms of any CP. And as I said, since we are in tramp, we are not a liner service. We are permitted to avoid bad weather. We are permitted to slow down in bad weather. Our system can detect that. We will obviously try to avoid the bad weather, maintain constant power, or circumvent the bad weather, or stop before the bad weather. And again, it's decision tools, it's recommendation tools. And these tools, the one I'm showing you right now, is available for our masters on board, and also for the shore organization, which is my part of the world, where I then can guide and support our masters for their passage. There are actually quite a number of people internally in our company who is daily monitoring these things to support the master in the decisions. Then alerts. Pascal also mentioned that it's a really big thing, and it's very, very, very effective that either a system or an email will inform a vessel that, hey, something is going to happen within the next 2, 3, 4 days. But not only the master, also the safety advisor, also the technical manager, also me, also the officer on the bridge, also the operator, and maybe even the customer. Some of our customers, they are very interested in understanding, is there a risk to the arrival time of the vessel, and how can we mitigate that risk? And if not, then what would be the consequence of that risk? It could be cyclones, it could just be normal areas, but it could also be something as simple as the risk of over-icing, as we have here in the Northern Hemisphere these days, or icebergs, or high seas. And they are simply just being repeated by emails. So very, very, very effective way of communicating, and by the way, also a very effective way of avoiding too many people, too many resources being involved, because it's just a computer sending a message to the master. The master has his bridge team. They will see the alert, and yes, we do send a lot of alerts, and yes, it does require some capacity on board. However, it is very, very effective and very proactive also, I should say. That was these alerts. And then this is our system, how it looked like. It's quite effective. We can see, just like many other systems, so there's nothing special as such about that. We present the weather, we present the alerts, we can simulate the voyages in time using algorithms, and we can present all the dangers that might be. And again, we have different scenes for different users. So the commercials will have one scene, the technical teams will have another scene. We have IoT for all our vessels, giving us all the relevant information about anything we need. This presentation was only about the voyage management, so that's what I have been trying to focus on. I think I am running out of time here, so let me stop it here and then go back to you, Evelina.
Thank you
Yeah.
very much for the presentation, Mr. Lajos. So, as I can see here at the Q&A, we have some questions for you. First of all, Mr. Peter, we have a question from, let me find it because we actually have a lot of questions right here. I tried replying to most of them. So, we have a question from Natalia Ivanova and says that, actually we have a question, this question is for Mr. Pasquale, sorry. So Mr. Pasquale, thank you for the interesting presentation. Have you estimated qualitatively how the deep learning model based weather forecast perform in comparison to physics-based forecasts? That is, do you have a number? For example, there is an improvement by X%. What is your level of confidence that you can trust more the non-physics-based forecasts? Thanks, Natalia from Oceanbird.
Yeah, this is a very tough question for me, actually. As you know, I'm just end user, so I'm not very much involved in the weather forecasts. What I can see is that actually, since we are putting on board sensors, and as I told you, accelerometer, and we are having real-time data coming from the anemometer, I can see that the data that are coming from master that is actually using these sensors, the data that are coming from weather are very close each other, comparing to the past that there was some lagging in terms of time. So really, this was discouraging, let's say, end operator by relying in those data. Instead, nowadays I see that the numbers are closer, very closer. I don't know how much is the percentage, but I see that really when we are going to check in real time what is going on board and what captain is reporting and what weather data are coming, so I see that are very close to. This gives higher confidence to all parties involved to choose the best way to proceed with the voyage. This is something that it's a question that maybe it's better for Peter, that maybe can add something more on the topic, since they are very close to weather as weather providers.
Okay.
I can happy to add quickly. I mean, AI-based weather models, they have significantly improved in accuracy over the last 15 to 18 months. And in some use cases today, they are even better, more accurate than a physical-based weather model. They have had some limitations, specifically related to wave heights and weather or wave pattern, and that's also now being improved in 2026. But with an AI-based weather forecast, you can in many cases improve the accuracy of more than half a day. So it's in that range. So we are not using that across shipping services yet, but we're using it in more location-based weather forecast to offshore installations and more spot weather forecast. Today we still use a global weather model from EC, but we are experimenting with it, and we believe we will see a gradual, much more relevance of AI-based weather models for shipping in 2026, when also you have more wave information in there.
Perfect. Thank you very much. Also, another question for you, Peter, from Ryan Ickholt. How do you find this vessel? How do you ensure? Let me start with Amit, and then I'm gonna jump to Ryan question. First of all, Amit Misra. Hi, Peter. How do you ensure the vessel's specific hazards and depth contours are not affecting the route for the vessel?
if I understand the question correctly, I mean, before we do anything or giving any advice for a vessel, we ask the customer, what is the thresholds? I mean, what vessel is this? What are your preferred limitations for weather and so forth? And we use all those thresholds when we are positioning the vessel and creating the route in the first place. But it's at all points an optimization between all these variables that I also talked about. Is how much, what is the limitation for the vessel, how much can it take, what is the required time of arrival in many cases. So my best general answer is it's a big optimization. That's also why it's something that is difficult for the people on board just to take by themselves, because this is the analytics optimization, like also Lajos was talking about.
Mm-hmm. Thank you very much for the answer. Then we have another question for Pascal, Mr. Pascal. Pasquale, sorry, excuse me. From Elisaveta Caterina. Dear Mr. Andersen, sorry. Elisaveta, yeah, perfect. Sorry, it is for Peter Andersen, this question. Okay. Thank you for your interesting presentation. Typically, how many days does the weather forecast cover? And is there any time framework in the forecast where the prediction is the most accurate? Also, in case of an unpredicted worsening of the weather condition, does the prediction automatically update itself? And what is the ratio of the vessels in the area informed about the changes?
Good question. We use a weather forecast up to 15 days. After 2 weeks, that is not very accurate. But down up to 4 or 5 days, the weather forecast is accurate. And of course, it's more accurate than the shorter forward in time you get. So the next day is very accurate. I can follow up with some percentages there. I don't want to throw out any percentages here and now. But typically, 4 or 5 days, you have a very reliable, accurate weather forecast. And if you're planning a route 14 days, it's important to have more information than 4 or 5 days. So we're using 15 days as a forecast. And if we are planning a voyage which is 20 days or 30 days, we're using statistical weather for that route, for that remaining time period. But then if there's remaining days of the voyage is less than 15 days, it's always a weather forecast.
Okay.
There was a last question of that question which I didn't get, but that was at least the 2 first part of the questions, I believe.
Yes, correct. Then we have another question. May I continue? Perfect. Okay. Then we have another question from Elisaveta Caterina. For Mr. Bisogno, thank you for your interesting presentation. I would like to ask you regarding the tracking and the limitations of potential hallucinations of the AI. How do you minimize them? And if and when they happen, what is used for the reality check?
Yeah, actually, as I said before, we are working together with our weather provider in order to improve the AI, let's say, reliability. Okay, so we have seen that at the beginning there was very much discrepancy on what we are expecting and what the AI agent was giving. For sure, we are now proceeding in parallel. So we are still working on our own tool. So the AI we are using just to speed up the process. Okay. So at the same time, we have built a tool in conjunction with this AI to understand how much is the, let's say, the reliability percentage of each answer. And of course, what we are working on is to set up procedure, circular letter, in order to interview the AI in a proper way. So as we have seen, if you give to AI very small difference in questioning, you are getting completely different answers. So this is something that we cannot accept. So Also on that, we are working in order to give to all end users the tool to give the proper question to AI and to have the, let's say, the reliable information. So of course, as I said, we are still working in parallel. So we cannot, other than we don't fully rely on AI, because AI needs training, needs to understand what is going on. So and also let's say the setup will take, I believe that will take other 2-3 years to be very much reliable and to give proper data to completely swap from let's say the job that we were doing so far and jumping to fully AI. So far we are just enjoying the speed up of the process. That's all.
Perfect. Thank
I don't know if I have answered the question.
Thank you very much. So then we have a question for Mr. Lajos, who I can see now he's just replying to, but maybe I can give you the question. How does your platform support standardized data models for interoperability, such as ISO 19848, with normalized classification model?
Yeah, so we don't do it directly, but example for the digital twin, we can do the simulation of the vessel, and we can do the efficiency of the engine next to the actual vessel. And then in our daily noon reporting system, we would then use the manually reported numbers for all the ISO standards. But for the digital twin, we can easily use IoT data sensors and then compare. And then if we need to go into more details, we would then probably ask our experts or ask the OEM experts for more detailed reviews.
Okay, and another question from Simone Haberl. Does any of the presented voyage optimization tools include fatigue damage monitoring to enable predictive maintenance of ship structures?
At the moment, we only use sensor technology to ascertain the movements. So example, how much is the vessel rolling in the current conditions? Because we would need that in order to do better guidance for the vessel. But we don't use it for fatigue, and we do not also use it for predictive maintenance. We don't use that, not at the moment. We do have the sensors. I think it's more a matter of resources. Down the line, we will definitely start using it. But at the moment, we only use it actively on the ongoing voyages to understand what the actual conditions are.
Okay, perfect. Thank you very much. And I have another question actually for all of you, which is more generally, what needs to happen in the next 3 to 5 years for decarbonization efforts to truly scale? And how could voyage optimization help in this initiative?
Shall I try?
Of course.
When we ask others what others are doing, and when we ask vendors where we are on the scale, I think, companies such as ourselves and D'Amico, who is also presented here, I think we're doing well, very well. I think the real potential are those who have not yet started this process yet, if we look at it from a world perspective. So I think if we look at it from a company perspective, we have been so lucky that we are permitted to spend money and to start investing in this area, and we can see the efforts, and we think, maybe I'm wrong, we think we're pretty good at it. When we look at our CII, I think we're doing a good job when we compare ourselves to the world fleet. Looking at it from a world perspective, the things we do here, if everybody were doing the same, it would have a huge effort on the world consumption, on the world fleet. Then you should, of course, ask what can we do better, and I think that's exactly what we're presenting here today. We are on a roadmap, and we have done a lot of things, but every time we turn a little corner, we find new things we can be better at. We can be better at the energy models. We can be better at the forecast models. We can be better at using AI in forecast. We can be better in the start of the voyage, in the understanding of the voyage. I think there's still work to do, but it doesn't mean that I think that we haven't come far already.
I can give a commentary as well as a service provider, a little bit different than Lajos. For us, at least as we see it, a key for further enabling here is collaboration. And it's an easy thing to say, but it's about that as a service provider, we are meeting many needs for Lajos and for others, but we cannot meet all. So we're also working very close with many customers on integrating the data that we host for them and we validate for our customers that they report to us every day, and then we use that for other purposes. Because you have a technical performance need for a vessel, you have a commercial, you have an environmental, and you have also many operational needs. You have maintenance needs and other types of planning, procurement, and so forth. I think a key here is close collaboration between many industry stakeholders, which we do already a lot from StormGeo, but also we want to do it even more, because that's more efficient than trying to solve everything as a service provider, which is unrealistic, because a ship owner operator has very many needs. So I think that's at least one key element. Also when it comes to AI, because AI is a tool here. Like Pascal says, it's not it's a game changer in how we work. It's not going to change. It's making us more efficient. It will not change in short term how vessels are managed and operate. There is an enabler for doing it more efficiently.
Yeah, if I can add some small words, of course, on the decarbonization journey, of course, AI is taking a big part, and to understand better how to invest, of course, we need an international regulation, especially on the CO2 emissions, how it is applied on international pattern, because as it is now, only on EU, of course, it's very complicated to us to calculate the return on investment on an investment we are doing. We are talking about AI, we are talking about technologies to put on board. It's very complicated for let's say a business as we are Trump business as we are doing. We are not liner, as Lajos saying. So it's very complicated to calculate the return on investment. So until when there is not a clear picture, let's say on a time level, it will be very complicated to understand on commercial, let's say on a charter party, why, let's say a client has to choose you that you are investing for, rather than other companies that are still a little bit back comparing to you. So of course, as company, we are trying to do our best, but of course, if you can have a clear picture on the return on investment that we are doing, for, of course, this will speed up the process, and it will be in line with the IMO requirements for 2030 up to 2050. That's for sure.
Thank you very much, all. So it's time that we close this webinar. Thank you all for joining us today. I would like to sincerely thank our speakers, Mr. Peter Andersen, who is the Vice President Shipping at StormGeo, Mr. Lajos Holmslykke, Head of Voyage Optimisation at TORM, then Pasquale Bisogno, Deputy Head of Performance and Decarbonization at D'Amico Ship. Of course, thank you to BS Group for organizing the session and StormGeo for sponsoring it. Your support makes these discussions possible, and they're very fruitful. So today's presentation highlighted how predictive analytics, AI, digital twins can improve the voyage planning and support real-time decisions in shipping. Finally, thank you to all the participants for your engagements, the questions. The Q&A was very active, actually, and we hope you leave inspired by the potential of these innovations. to make shipping smarter, safer, and of course more sustainable. Thank you and have a great evening.
Thank you, Evelina. Thank you
Thank
all.
you very much.
Thank you.
Thank
Bye-bye.
you.
you.
Bye-bye. Bye-bye.
Bye.